I'll go over what PyTorch is, who should use it, and show you some basic examples. PyTorch is an open source machine learning library developed by Facebook's AI Research Lab. It is widely used for applications in deep learning and provides a flexible framework for building and training neural networks. Its dynamic computation graph allows users to change the way their networks behave on the fly, making it ideal for research and production. Let's now get into some code. You can install PyTorch using pip. This command installs the core PyTorch library, along with Torch Vision for image processing and Torch Audio for audio processing. If you're on Windows, I recommend using Conda to install it. This installs PyTorch and its associated libraries in a Conda environment, ensuring compatibility and ease of use. Ensure you have Python 3.6 or later, and Conda installed. Now we'll import the necessary modules from PyTorch. Torch is the core library, torch.nm provides neural network components, and torch.optim contains optimization algorithms. Now let's create a sample neural network. This code defines a simple feed-forward neural network with two layers. The first layer transforms input data from 10 features to 5, followed by a ReLU activation, and the second layer maps the 5 features to 2 output classes. Now let's train it. In this section, we set up a training loop for our neural network. For 100 epochs, we generate random input data, compute the model's predictions, calculate the loss, and update the model's parameters to minimize the loss. Now I'll show you how to save it and load it. This code demonstrates how to save and load model weights. Saving the state dict allows you to store only the parameters, which is more efficient than saving your entire model. Remember, start simple. Begin with basic models and gradually add complexity as you become more comfortable. Leverage torchvision.models for pre-trained models to save time and resources, and familiarize yourself with PyTorch tensors, as they are core building blocks for all operation. When debugging, utilize the dynamic nature of PyTorch for easier debugging. Use print statements to inspect tensors at various stages. Use PyTorch data loaders for efficient data loading and batching. Ensure data is normalized before training. And monitor validation loss and consider using techniques like dropout or data augmentation to avoid overfitting. Thanks for watching. If this video was helpful, please like and subscribe to our channel for more tips and tutorials.